Hello everyone, and welcome to the live coding section of the errors and exception handling part of this course. And now we're going to learn how to use try, except, and finally, which we learned about in context in the previous video. Now we're actually going to use them. So let's go ahead and see if we can get an exception to occur or some sort of error. I'm going to say 2 plus, and I'm going to try to add a string to it. Now clearly this isn't possible, so I get a type error. There's unsupported operands plus for an integer and a string. Okay, that makes sense. So I could have said try, and now here I'm going to put in code that I think may put an error out or some sort of exception. So it says try 2 plus s. And now I'm going to put in the except block, and I'm going to say except if there's a type error, print there was a type error. And let's see what happens now. So if you notice, I mentioned that some of these exceptions are not unconditionally fatal. Type error is one of them. So type error, since it's not unconditionally fatal, the rest of your code can actually still run using this try and except format. So what happens is the code tries to do 2 plus s, except there's a type error, so it prints there was a type error. And then the finally block we'll execute any code after these exceptions. So we'll say finally, we'll say print, finally this was printed. So now if we run this, we get both the except statement and finally this was printed. So something to note here is that I don't actually have to specify what error it is. Otherwise that would require you memorizing the entire list of exceptions. But if you go back to the Jupyter Notebook and scroll down, I do have a link there to check out the full list of built-in exceptions in Python, and you can check them out all here. So you can just go ahead and, if you want, generally browse this, but there's no point in memorizing all of these. This is just to help you debug your code later on. So if I just say except, I don't actually need to know or guess what kind of error is going to pop up. If I run this cell, you'll notice I get the exact same thing. Okay, so this is how you're usually going to see try, except, finally used in your own code. You're probably not going to type in the actual exceptions that you expect to occur. All right, so let's go ahead and break down exceptions with a try, except, else sort of statement. So I'm going to do this by trying to open a file. So I'm going to say try, say f equals open. I'm going to try to open test file. With being able to write to it, I'm going to say f dot write test write this. And then what's going to happen is, let me go ahead and make sure I don't have this file by adding in some numbers. So it's going to try to open a file that's not there. And I'm going to say except print error in writing to the file. And I'm going to say else print file write was a success. And if I run this, it says file write was a success. Now that's because when I open a file like this, it'll actually create the file for me. So I opened the file, test file 1232. The file didn't exist, so Python went ahead and wrote it for me. And now if I look at my folder, I'll have a test file 1232 that says test write this. So file write was a success. So that's how you can use else. So when you don't have any exceptions, else will help you know that. So it says try this, except if there's an error, print out an error, else if there's no exceptions and everything went well, execute this code block. Now I'm going to try to induce an error by saying read. So remember from file opening and closing, if I just put R, that means I can only read the file. I don't have write permission. So now let's see what happens if I run this cell. No, I have an error in writing to the file. Great. So we only printed a statement and the code still ran. So we're able to continue doing actions and running code blocks even if I do have an error occur, which is really nice. So it's super useful when you have to account for possible input errors in your code. So you can be prepared for the error and keep running code instead of your code just breaking the minute it sees some sort of exception occur. So we could have also just said except if we weren't sure if a certain exception would occur. So for instance, I know that this sort of error is called an IO error, and that's fine. But I can also just put except. I just want to make that clear that you don't actually have to put in what kind of error will actually occur. All right, now continuing on. Right now we have this else statement that will execute only if errors don't occur, right? But what if we wanted to continue doing stuff even if an error occurred? So that's where the finally block of code will run. So that will run regardless if there's an exception. Right now we have try except else, so it's going to try some code. If there's an exception, it'll do this. Otherwise, or else, it'll do that code block. But what if we wanted to do this code block regardless if there's an exception or not? So we're going to use finally to do that. So I'm going to say try. Let's say try this code right here and say finally print always execute finally code blocks. So if you notice, even if there was an error that occurred, finally was still able to print always execute finally code blocks. So what happened here? So I had to try this, I got an error, and then finally still occurred even if there was an IO error there. So I can write an except. I'll do it for any error and print there was an error. And let's see what happens now. So if you notice, this except block of code basically eliminates Python's built-in output for exception handling, or the errors popping up. So you can write in your own except and print there was an error, so your code's a little cleaner, and then have a finally block that will always execute. All right, so what we're going to do is use this in conjunction with asking a user for input. So I'm going to say make a function. Let me zoom in a bit here. Make a function, def, and I'm going to call it ask int. And what it's going to do is it's going to try to set a variable val equal to raw input. I'm using raw input because I'm using Python 2. If you're using Python 3, you may just use input. I'm going to say please enter in integer. Okay, and what I'm going to try to do after that is convert it to an integer. I'm going to put an except statement that says print looks like you did not enter an integer. Then after that, I'm going to say finally print finally block executed. And then I'm going to say print the val. Okay, so let me zoom out now so we can see the whole thing. All right, so I have my function here, ask int. It's going to try to take whatever raw input the user puts in, convert it to an integer, and set that equal to val. If there's an exception that occurs, it's going to occur because I wasn't able to convert whatever they put in as an integer. So I'm going to print, looks like you did not enter an integer. Finally, whether or not there's an exception, I'm going to print finally block executed. And then I'm going to print the val. So let's see if this works. Let's go ahead and ask int, close parentheses, there's no arguments. I run it. It says, please enter an integer. I'm going to enter 3. Finally block executed, val was equal to 3. All right, perfect. So let's try this again. I'm going to say ask int. It says, please enter an integer. Now let's say I was confused and I entered 5. So if you notice here, it says looks like you did not enter an integer. Finally block executed. And we have an extra error because we're trying to locate the variable val before it was actually assigned. And that's because this print val is outside the finally code block. Okay. So we got an error when we're trying to print val, notice, because it's never properly assigned. So we can go ahead and remedy this by asking the user and checking to make sure the input type is an integer. So what I'm going to do now is in my except block, I'm going to say val equals int raw input. I'm going to say try again. Please enter in integer. Okay, so let's break down what the code's doing. I'm going to space it out so it's a little more clear. So now my function, what it's going to do is it's going to try to take the raw input a user puts in, convert it to an integer, and set that equal to val. If there's an exception that occurs, it's going to say, looks like you did not enter an integer. And then it's going to do it again. It's going to try again, please enter an integer, raw input, convert it to an integer. Finally, it's going to print, finally block executed, print val. Okay, so I ran that. Let's go ahead and see what happens. Ask ints, put an integer. I'm going to put in 5. It says, looks like you did not enter an integer. Try again, please enter an integer. Now if I put in 5, everything works. Great. So that only did one check. If you notice, if I tried this again and mess up twice, so ask int, please enter an integer. Let's say I put in 5. It says try again, please enter an integer. Let's say I put in 5 again. We're going to get an error now, a value error, right? Because it's not able to convert 5 into an integer. So what can I do to try to keep continually checking? Well, hopefully your mind's thinking about a while loop, right? I want to do this statement over and over again, raw input, check for an integer, until the user actually puts in something correct. So I'm going to start again. I'm going to say def ask int, and I'm going to say while true, try to set val equal to that integer raw input of please enter an integer. If there's an exception that occurs, I say except print looks like you didn't, whoops. Let's make this a double quote so I don't have to worry about that single quote inside. Looks like you didn't enter in integer. And then I'm going to continue. Else, so remember, else happens when the try is actually correct, so I'm going to print correct. That is an integer. And then once I know it's correct, I'm just going to break out of that loop, that finally loop, or excuse me, that while loop. Then finally, after that, I'm going to print, again, finally block executed. And then outside of this, I'm going to print the value. Okay. So let's break down real quickly what's happening here. I'm going to say while true, so basically forever, try to get the input here, the first question. So this is like the very first output. It says, please enter an integer, and let's say there's an exception that occurs. I print, looks like you didn't enter an integer, continue. And then it comes back up here, tries it again, accept, continue. So this is going to keep going forever until we get a correct input where there's no error. And it's going to say else, print correct, that's an integer, and that will break that while loop there, and then it's going to say finally print the code executed, print val. So let's go ahead and see if this works. I'm going to say ask int, please enter an integer. I'm going to put E, which I know it's not. I'm going to put R. So if you notice, my finally block is always being executed, even though I'm having these errors. But the second I put in a correct number, with that else statement, it says correct, this is an integer, and then the last time the finally block is executed. All right. So that's actually it for this video lecture. So we're just going to go quickly over everything we did. So try except finally. The very first thing we did was put in a type error exception. So 2 plus a string, that didn't make any sense. So we noticed we could use try. So I'm trying to execute this block of code, except if there's any sort of exception, I print finally there was a type error, or excuse me, I print there was a type error. Then finally, this block of code will always execute whether or not there's an exception that occurs. Again, here I said try. I said open this test file. Remember we switched from writing to reading permissions. So if there was an error that occurred, I said there was an error. Finally, always executes this code block. Then we started exploring how to deal with user inputs that are incorrect. So we made this function. In this case, I say try, take the raw input, try to convert it to an integer and set that as val. Is there any exception? Then I print, looks like you did not enter an integer. Put raw input again, try it again, but this only works twice, right? Since it's not in the while loop. And then finally, the block's executed, and we try to print, and then we print val. And again, if you mess up twice in a row, we're still getting a value error there. So how do we continue doing this forever? Well, that's where the while loop comes in. So we say while true, try this block. If there's an exception, print that and continue, which means it's going to try it again. And it's going to keep going, and then we can put an else block, which says if there's no exception there, then print correct, that's an integer, and then we break out of that loop. Then finally, this always executes whether or not there is an exception. So you notice here, even when there was an error here, and I say it looks like you didn't enter an integer, the finally block was always executed every single time. And then at the end, when I did get it right, it says correct, that is an integer, that else block executed, and then I printed finally block executed. Okay, great. So that's it for this lecture. Go ahead and explore try except finally a little more. It's going to be super useful in your beginning code when you're trying to handle user input that you think may be incorrect. But later on, you'll use it more and more. Just be careful with it though, because you don't want try statements everywhere in your code. Otherwise, it gets harder and harder to actually debug your code unless you put in very clear print statements for your exceptions. So you can imagine if your code's kind of always running these finally blocks and you have a ton of try blocks in there, it might be hard to pinpoint where the actual error is taking place if all your print statements are there was an error or something for the exception blocks. So this is super powerful and it's a really great tool, but just be careful with it and make sure you use it well when you code. Okay, thanks everyone, and I'll see you at the next lecture.